Hi everybody and welcome. Today we're going to be looking at a new skill, relying on a lot of things we've honestly used over the past few lessons. So if you've been following along for the past few lessons today, you should have a pretty solid basis for what we're about to look into. So the skill we're going to be looking at today, and your goal after watching these two videos, is going to be able to identify, graph, and look at the major properties of an ellipse. So extremely similar to circles, just some minor changes that make it more oblong instead of a perfect circle. So what is an ellipse? So the formal math definition of an ellipse is a set of points such that the distance from the foci remains constant. So foci, in this case, is actually going to be two focuses. And pretty similar to a parabola in that way, the only difference, instead of just having that one focus here, we're going to have two. So again, a bit more in depth, but relying on a lot of the same principles. And the equation actually looks pretty similar to the equation of a circle as well. There's just going to be a few more vocab words that we're going to need to know for these, a few more properties to define. So if we have an ellipse, something like this, I'm going to redraw that because I did not do a very good job. You know what? I cannot draw these very well. My fatal flaw. All right, so a couple different vocab words here that we need to basically identify and remember. So here, the longer axis is our major axis. So the ellipse is longer on that axis. If it's up and down, basically if you rotated this up 90 degrees, it would be different, but in this case, this is the longest length. In yellow, that's our minor axis. And this totally depends on where is it shortest. So here, again, going from here down, that's the shortest length, so that's why that's the minor axis. Other things that you probably have seen before, that point right there is the center. A few other words as well. That is a vertex. That is a vertex. And the vertex is always on the major axis. We have something else called a co-vertex. And that's always on the minor axis. Other things to identify here, basically just left with the focus, or the foci, focus and focus. So two individual focus make up the foci. But other than that, those are the major vocab words that we're looking at here. And again, any point on this we're looking at as a relationship to, like, so if it's this point, for example, looking at that relationship of the distance from the focus to that point. So any point on the circle, the length of the lines from focus to focus would be exactly the same if you add both of them up together. So that's the idea for an ellipse. So now that we are here, some equations that we can take based off of this. So this would be one with a major axis on the x-axis. Would be as follows: x squared plus y squared over a squared and b squared equals 1. So pretty similar to the circle. The only thing that's different from the equation of a circle is we're adding in these a squared and b squared terms. And a few properties here. A is bigger than b, and they're both greater than 0, sorry. So for a non-zero quantity, we're saying that this is bigger and that this is smaller. And again, that is going to be our ellipse that looks like that. Similarly, and we can actually draw it right next to it, if we have a major axis on the y-axis, same setup, except b squared is under x now. So what this means is that it kind of goes up and down. So now this, should I do that right, is our big, and this is our smaller number. And based off of this, a few things that we can identify, some things we need to know. A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. And C is the distance from the center to the focus. And we can basically use these things to solve. And another helpful equation that we're given is b squared equals a squared minus c squared. And again, still going off of those right triangle properties. And if you want to go over that proof in class, we definitely can. But again, that same idea. So we can use this and this and this to basically solve. And we'll go over two different types of questions that you're going to see off of this first video. A lot of notes for this for sure, so I would definitely pause, rewind, do what you need to do to make sure that you get these copied down. But again, looking at two different types of ellipses, one where it goes left to right, one where it goes up and down. All right, so we are given that a focus for an ellipse is at -12, 0. We're also given that a vertex is at 13, 0, and they want us to find the equation. So my advice when you're given points is just take a look. What does it look like? So here we have a vertex at +13, 0. We have a focus at -12, 0. Now we know that if we have one vertex at 13, 0, that the other vertex is a mirror image. So there must be another one right next to that focus there. And the same thing for our focuses, mirror image of each other. So there's also a positive focus on this side as well. So those are two things that can help us out. Additionally, we know that the center is at the origin. Okay, so those are actually quite a few points. The only things that we're missing are what are the coordinates of the co-vertex? So we know that there's two of them, we just don't know where are they. And once we find that out, we'll basically be able to go through and solve. So first things first, the distance from the center to our vertex, if that's 13, 0, is 13. And then the distance from the center to the focus, if that's 12, 0, is 12. So if we're going back to our properties here for A, B, and C, it looks like we can identify a few of these points. So distance from the center to the vertex is 13, that's A. Distance from the center to the focus, that's C, is 12. And we have an equation we can use, b squared equals a squared minus c squared. So we can plug in a squared is 13 squared minus c squared is 12 squared, and all of that equals b squared. So 169 minus 144 equals b squared. You can subtract these to get 25, and then finally take the root. So b in this case equals +5. Okay, so going back to our equations from above, we know that this is going to be a long left to right ellipse, so we're going to use this equation here. So x squared plus y squared, and then it's over a squared, and then over b squared equals 1. And we just solve for a and b. So we have a, we have b, so we can plug those in. So x squared over 169 plus y squared over 25 equals 1. And we've successfully solved for that equation. So to recap, we basically just needed to find a, b, and c. Once we found those, we can plug them into our equation. And that would be our final answer. All right, a second type of question that you might find is a graphing question. So it might ask you to graph based off of an equation. So x squared plus y squared over 16 over 25 equals 1. And in this case, this is our big number. And if our big number is on the right side, we're going to be using an up and down vertex, or ellipse. So it's going to be looking something like this. All right, so we have a squared equals 25. We have b squared equals 16. So we know that we take the root of those, a equals 5 and b equals 4. So now we need to find our c value. So b squared equals a squared minus c squared. So let's see, 16 equals 25 minus c squared. Or we can rearrange these terms. So c squared equals 9. When we subtract 16 and 25, take our root. In this case, c equals 3. So now we have a, b, and c. So we can use these to define what we're looking for. So c is the distance from the center to the focus. So that's positive 3, and that's negative 3. B is the distance from the center to the co-vertex. So here, that would be 4, and that would be negative 4. And then A is the distance from the center to the vertex. So that would be 5, and then that would be minus 5. So our ellipse is going to look something like that. So not a perfect circle, a little bit stretched out, but by identifying A, B, and C, we can graph the important terms, and that's going to allow us to solve. All right, everybody, so a bit of a longer intro video here, but quite a few skills to cover. You're going to be able to practice doing a graphing question and solving for an equation question. Our second video is going to basically go through very similar questions, but what happens when the vertex is not, or sorry, what happens when the center is not at the origin. All right, everybody, be looking for that second video.